Hello, friends. Welcome back to our data analysis in SPSS series. Now, again, my name is Dr. Lohua Mahmudu, and today we are going to look at simple linear regression analysis. Now, simple linear regression analysis is actually used in finding whether or not there is a relationship between two continuous variables. Now, with this continuous variable, one of the variables is the dependent variable, which is sometimes called the outcome variable or the target variable. And then the other variable is known as the independent variable, which is also sometimes called the explanatory variable, the predictor, the contributable variable, the attributable variable. So these are all names given to the independent variable. So how are you able to actually make conclusion regarding the relationship between a given dependent variable and then an outcome variable if you have a predictor, or independent variable if they are both continuous. To do that, you can actually use simple linear regression to be able to establish this relationship. And simple linear regression analysis can also help you to make prediction given the dependent variable and then the independent variable. You can actually use the independent variable to predict the dependent variable. Now, what you should know is the fact that the independent variable is a predictor, which is going to actually use in predicting the outcome. So before you perform any linear regression, you should be able to know your outcome and to make sure the outcome variable, the independent variable could possibly predict the outcome variable. So now let's get to it. How do we use SPSS in performing a simple linear regression of two given variables, one being the outcome variable and then the other one being the independent variable. So again, there is also the inference part of our data analysis series in SPSS. So let's get to it. So now to do that, so we have our data. Again, we are using the same data we have been actually looking at from the previous series. So now, if you want to perform any regression analysis, first of all, again, you should be able to identify your continuous variable. So in this data, we have age as a continuous variable or scale. We have a weight of the student also as a continuous variable. We have the height of the student also as a continuous variable. And then we also have the GPA as a continuous variable. So now, before you can proceed, you don't just jump to perform linear regression analysis because you are just interested in performing the linear regression given the two continuous variables. You have to be able to actually ask yourself a question, which actually you think is a legitimate and a question that actually make a sense in terms of research things. But for the purpose of this analysis, let's assume we ask ourselves this question: does student age influence the student GPA? So we would want to actually assess to see whether the age of the student have any impact or influence on the GPA of the student. So if that happens, what then becomes our predictor or independent variable, and what is our dependent variable? Since we are looking at assessing whether age have impact on GPA, GPA becomes our outcome variable or the dependent variable. And then the age now becomes the independent variable, the predictor or the explanatory, the contributable, the attributable variable. So now, having been able to establish the differences between these two variables we would want to investigate, let's proceed to perform our analysis. So to do that, now we go to analyze, and then we would want to use regression. So there will be a drop-down menu, then you click on linear. Now we want to just perform a simple linear regression. Whenever you hear simple linear regression, it's just a regression analysis with only one independent variable or one predictor. So now when we click on it, so we have this information here. So first of all, let's drag this information into this box. Now, the question we posed to ourselves was to see whether age influenced GPA. So now what it means is that our GPA becomes the dependent variable. So we want to see whether GPA depends on age. So then we have to push it into the dependent variable. And then we now push the age into this particular variable, into this box, into the second box, which is representing the block box. So now we leave everything as it is. Now you can go to statistics, and then you might want to perform a certain. Now by default, SPSS have only this one check, which is the estimate. But then maybe you might want to go further to see maybe the model fit, and then you might want to perhaps maybe see certain covariance metrics. These are maybe the Darby-Marston test to see maybe the multicollinearity within. These are advanced analysis you might want to think of, but let's just leave it at the estimate and then the model fit. And then you go to continue. Now, once you go to continue, if you want to display any plot, you can actually, so maybe assuming we would want to, let's say, display a normality plot to see whether the residuals of of our model is normal. So we can just do it. And then maybe if you want to see some histogram, you can just click on maybe the histogram of the residual to see how the histogram looks like. So now you click on continue, and then you click on OK. So now once you click on OK, these are the information that is being displayed. So you have the variable entered and removed. So there's the model selection part. Since we have only one independent variable, there's no need for a model selection. And then there is the model summary. So this model summary is giving you your R-squared, adjusted R-squared, and then the standard error of the estimate. Now the R-squared tells you the variation in the dependent variable, which is being explained by the independent variable. So how much variation in the dependent variable is explained by the independent variable. In other words, how much variation in GPA is being explained by the age of the student. So now, over here, the R-square is 0.04, which is not even up to 1%. So there's a very, very bad R-square. But so it tells you that, let's say, 0.4% variation in GPA is explained by the student's age, which doesn't actually make sense. So now, again, we proceed to the ANOVA table. And this ANOVA table is actually telling you the significance of the test we have performed. So what is the significance of the regression test we have performed? And then to be able to see that, you look at the SIG over here. And the SIG here, what do we have? We have 0.569. The SIG here is representing the p-value. Again, a very high p-value. By having a very high p-value, it means that it is statistically not significant. So in other words, it means the model is not significant. Now we can proceed to the coefficient to see the relationship between the dependent variable and then the coefficient. So in the coefficient, you have the constant or the intercept, and then you have our independent variable or predictor, which is age. Now you have B here, which is representing the coefficients of each of the independent variables, and then the constant, and then you have the standard error. So again, to be able to assess how does age influence GPA, we look at the SIG here. And then under the SIG, which also represents the p-value, we have a p-value of 0.569, which is a very high p-value. So in this case, it means there is no significant difference between the GPA and the student age. So in other words, age is not a good predictor of GPA in this data. So in other words, we conclude that age have no influence on what? Influence on data. But then you can see our constant is what? Is significant. But anyway, we are not interested in the constant. So we are interested in our independent variable age. So in this case, by having a large p-value of 0.569, we conclude that the age is not statistically significant. In other words, age have no influence on the GPA of student. And these are some residual statistics you might want to look at. And then there is what the normality plot. And by looking at this normality plot, I mean, it tells you that it is fairly what the residuals are fairly normal. And one thing you would always want to do, particularly when performing regression analysis, is to be able to satisfy certain assumptions of performing linear regression analysis. And in another series, we'll be actually going detail into how to satisfy some of these assumptions. But however, by looking at it, you can say that since this line cross almost the data points, now we can say that it is what the residuals are fairly normal, although some of them are outside the line, but it is not too far from being normal. So you can see that it's fairly normal. So this is how you can actually perform an inferences to establish the relationship between two continuous variables, or to be able to assess whether one continuous variable, which is the independent variable, have an impact on another continuous variable, which is what? A dependent variable. And you do that using what? A simple linear regression. And again, simple linear regression allows you to have only one independent variable as a variable to be investigated. So in any given simple linear regression analysis, you have one outcome, which is the dependent variable, and you also have only one outcome, which is the independent variable. So in conclusion, we can conclude that given this large p-value, we conclude that age of the student have no influence on the GPA of the student. I hope you enjoyed this section. I hope you have been able to understand a little bit when it comes to linear regression, especially simple linear regression. So I will see you in another lecture or series of this data analysis in SPSS series. So thank you very much for watching, and see you in our next series. Bye-bye.